said a time over there. Performance is not
Should be good.
it's actually already recording. It's a bit irritating.
Oh no, probably for this it's 11:10.
Okay, well, stop whenever you feel like it.
See if we get a couple more people, I guess. Of course, if you see any collaboration opportunities in any of this,
Sure.
if you want to fall asleep.
So I can do that as well. It's so comfortable here.
Might as well start. Oh yeah, and you want me to use the microphone? Right. So it's on?
Top.
Oh, it says it's on. Doesn't sound like it's on. All right, let's get started. Most of you already know me anyway. So my name is ChristophTreude. I'm one of Marcus's colleagues. My office is just 2 doors down from his. And I'm one of the faculty members who's in software engineering. And what I'd like to talk to you about today is 2 or 3 projects. We'll see how we go in terms of time that we've done over the last couple of years in terms of research on software engineering. And why I picked these particular projects to talk to you about is I believe that all of them could benefit from search-based software engineering, optimization in general. We haven't really pushed any of them in that direction, but I'm looking forward to hearing about your ideas how we could do that. Because we are such a small crowd, we might as well make this quite interactive. So if you have any questions, comments during this, feel free to interrupt at any time. So the first project I'd like to talk to you about is something we did a couple of years ago. And I have a little motivating scenario on this next slide. Let me just pull up the part that I actually want to focus on here. So as most of you, I'm sure, are able to tell, this is a thread from Stack Overflow. I'm sure you've all seen Stack Overflow before. It's a question about the difference between data source and driver manager in Java. And you can see in the answer that the person answering the question actually quotes the official API documentation, which says an alternative to the driver manager facility, a data source object is a preferred means of getting a connection. That's all it actually says in the API documentation about the difference between these 2 things. It doesn't tell you why you should use one over the other. It doesn't tell you why there are 2 to begin with. It doesn't tell you what the context is, and so on. So it's not necessarily a good piece of API documentation there. However, as you can also see, the person who answered the question on Stack Overflow adds a nice extra sentence there. Normally, you use driver manager when you just want a connection for one time, while with data source, you get all these other features. So really useful information, the kind of information that you would think should ideally have been in the API documentation to begin with. Instead, it's buried in an answer on Stack Overflow. There's been lots of research finding that API documentation and Stack Overflow are quite different, unsurprisingly. So there's been lots of research finding that API documentation is really good at covering the functionality and the structure of the API. So after you read API documentation, you typically know exactly, inheritance structures and stuff like that, which just from reading Stack Overflow you might not get. However, API documentation has also been found to be really poor at documenting concepts. So, what is a database connection to begin with? The purpose, why is there this API element and this other API element, and which one should you use in what situation? The overall design, rationale, code examples, example scenarios, and so on. So I'm sure everybody who's used API documentation has encountered exactly these kinds of problems. And that is partly why we use Stack Overflow as much as we do, because Stack Overflow is really good at documenting these how-to scenarios. If you have a specific question and just need to get something done, Stack Overflow is actually pretty good at that. So Stack Overflow and API documentation, in this case, they are good at different things, but they rarely function well together. So what we were trying to do in this work is, as the title of the paper and the slide deck suggests, is to basically augment API documentation with insights from Stack Overflow. So can we develop an approach that automatically finds these really nice nuggets of information on Stack Overflow and puts them into API documentation? In this particular project, we never really pushed this very far in terms of user interface. But for those of you who are more visual people, it might help to have an idea of what we could be thinking about here. So this could be a browser plugin, right? Whenever you look at API documentation, there's lots of white space in the upper right corner. And this is where you could put sentences that you have automatically extracted from Stack Overflow that are useful in some way. The focus of this part of the lecture is not on the user interface for this, but just so you have an idea what this could look like. So to make this happen, we came up with this definition of what we call an insight sentence. And we say this is a sentence from Stack Overflow that's related to a particular API type and provides insight that's not contained in the API documentation of that same type. Now this definition is limited to Stack Overflow and API documentation. I'm hoping you can see that this could be broader than this. We can maybe get insights from blog posts and put them into wiki pages, and insights from GitHub issues and put them into Stack Overflow threads and so on. But we needed to start somewhere, and our starting point was, can we find useful stuff on Stack Overflow and put it into API documentation? To do this, we looked at two research questions. The first one was, to what extent are different approaches, and we looked at unsupervised and supervised, able to identify such sentences? And the second one, do people actually find this useful? Like, is this worth doing? To tell you sort of about how we did this, a few different steps. The first one was because we want to identify sentences on Stack Overflow that are related to a particular type of the API, such as driver manager. We need to somehow we need to identify relevant Stack Overflow threads to begin with, right? If we want to find useful sentences about the driver manager in Java, we don't want to look at Python threads, for example. Then we needed to create a development set or a training set, depending on which particular use case we have for it afterwards. Then we looked at 4 different ways to make this happen, and I'll talk in detail about all of these. And finally, we did a study to compare all of them. Let's start at the top. So what did we do to identify Stack Overflow threads that are related to a particular part of the Java API in this case? So all of what we did here was limited to Java. It should be pretty easy to adopt this for other programming languages as well. We haven't actually done this yet. So Stack Overflow has an API. I don't know if any of you have actually played with this yet. And for this particular query, we focused on sorting Stack Overflow threads by relevance, so that's sort of the inherent ordering that Stack Overflow gives you back. We only looked for things that were tagged with Java, and for the query, we searched for the particular API type which we are trying to find related threads for, in the example, driver manager. Marcus has a question.
What does relevance mean?
Relevance in this case, I don't know how the algorithm works internally exactly, but it has something to do with how frequently the word occurs, basically that.
Okay, so some internal black box.
In this case, it's an internal black box. The alternatives would have been sorting by, what was the other one, by number of votes, I think, and when the most recent, or something like that. But relevance seemed to work best. So as you'll see on the next slide, one of the challenges is actually to find relevant Stack Overflow threads, and this one gave us the best mapping. Yeah, let's see if the next slides answer your questions satisfactorily. So one of the challenges with this is it works reasonably well if the API type that you put in consists of multiple words like driver manager, because driver manager, chances are if you have a Stack Overflow thread that's related to Java and it talks about driver manager without a space in between, chances are it actually talks about the particular class driver manager. The same does not necessarily apply to things like string. So just because you mention the word string in a thread doesn't necessarily mean you talk about the API type string, or what would be map. Map's another good example, right? These one-word API types. So we then did some filtering after that. I'm not going to go through all the details of the regular expressions here, but we basically had 5 different regular expressions, and I believe if the thread met at least one of these conditions, yeah, not all of them, at least one, then we consider it relevant. If it doesn't meet at least one, then we don't consider it relevant. The explanations are in italics and brackets under the regular expressions. So we search for things such as the fully qualified API type. So if somebody mentions java.util.string, we can be very confident that they are actually talking about the API type. If in the title it says a string rather than just something string, we can be more confident. And then we did a manual evaluation of this to see whether it actually worked. So that's probably the more interesting part. So we took 40 randomly sampled API types of the Java, I think this was Java 8 at the time, of the Java 8 API, 20 that consisted of a single word such as list, and 20 that consisted of multiple words such as array list. And we manually went through the threads that it returned and looked, is this actually a thread about the specific API type, or just talking about lists in general? How do I implement a list with vector, for example? Well, then it would be about vector, not about list. And yeah, as you can see, the F measure worked pretty well. For multi-word API types, it works better, unsurprisingly, than for single word types. Does that answer your question? Okay. So that's how we linked Stack Overflow threads to specific API types. One of the design decisions we made at that time was to do this based on live queries through the Stack Overflow API, rather than what you could also do, download the entire Stack Overflow data. They release a data dump every couple of months, and do it based on that, partly because we wanted to be able to include real-time results. That was a design decision, and you could have gone the other way as well. All right. So the next step we needed to do was create a development set, or then later on when we started using machine learning, this became our training set of sentences that we actually wanted to identify. So the decisions we made here was, first we wanted stratified sampling, and we wanted a development set, and we also wanted an evaluation set that we could later on use to evaluate the whole thing. Stratified sampling, why did we do this? As you might be aware, in particular the Java API, but I think this is true for all APIs, there are some API types that are used a lot and some that are super rare and that you never use and that you don't actually need any tools to extract sentences from Stack Overflow. So so I think the Java 9 API now has either 5,000 or 6,000 API types, and not all of them are used all the time. And at the same time, if we had just done a random sample across all of them, we would have picked so many that are really rare and will never be used anyway, that we wanted something else. So we wanted stratified sampling. We relied on some related work that's 8 years old by now, but what they did was they analyzed lots of source code to see which parts of the Java API are actually used, based on package level and also based on class level. And what we did was we looked at the top 10 packages, because everything that's not in the top 10 packages is quite a bit less likely to be used then. And for each of these, we picked the most common one to be in the evaluation set, the second most common one to be in our training set, and the third most common one in the evaluation set again. So that was our attempt of balancing this a little bit, using a systematic approach, but at the same time picking things that are somewhat commonly used, but not only the most commonly used ones. So in the end, we had 10 API types, one from each of those top 10 packages in the development set, and 20, the number 1 and number 3 in each of these packages in the evaluation set. And then we use these API types to retrieve relevant threads on Stack Overflow from Stack Overflow using the approach that I had on the last couple of slides. Okay. So the first research question we wanted to address was to what extent are different approaches able to identify meaningful inside sentences in all of these sentences that we get from Stack Overflow. For that, we need to know what meaningful sentences are. So we needed lots of meaningful and also lots of meaningless sentences. So we did a lot of manual data annotation. Please don't read everything on that slide. We went through, based on this strategy of identifying relevant Stack Overflow threads for API types, we went through a total of, I think, 1,500 some sentences on Stack Overflow and manually annotated each one in terms of whether it was meaningful and useful in our particular scenario, yes or no. Turns out most of them are not useful on their own, because if you take a sentence just out of its context, it doesn't make so much sense anymore. I think my favorite example from this data set was "not too shabby" as, a sentence. And this is obviously not the kind of sentence you want to extract from Stack Overflow and put in API documentation. However, you have other useful ones in there as well as, the example here, normally used driver manager and so on. Hamish.
So was every sentence from a Stack Overflow, relevant Stack Overflow question extracted individually and analyzed? Is that what?
Yes. So we, I believe we limited it to the most relevant 10 Stack Overflow threads for those 10 API types. So we started from 10 API types that were in the development set, then extracted, I think it was 10. I have to look at the paper again. Extracted the 10 most relevant Stack Overflow threads according to this methodology, and then went through manually to analyze.
Extracted out every single sentence and put them on their own?
Yes, yeah.
Did you consider the comments on Stack Overflow? Because
In-
quite often comments have
Right.
clarifications or edits.
In this case, we didn't. If we have time today, the third part of the lecture is actually mostly going to be about that. In this particular one, we didn't. But I absolutely agree that comments are a very interesting source of data. And it turns out, I didn't really know the numbers either until we started looking into this in more detail. So I think Stack Overflow, as of now, has about, what was it? I think it's close to 40 million posts. So it's like something like 16 million questions and 20-some million answers, roughly. So if I count post as either question or answer, and I think it was 70 million comments. So more comments than anything else. So there's definitely lots of interesting stuff in there, Hamish.
So you got the most relevant threads, and was it every question from that, or just the best? Was it the highest voted or the accepted?
You mean answer?
Oh, answer, sorry, yes. Or was it every answer?
I believe we went through every.
Okay.
Yeah. Again, that was a design decision where we could have gone a different way. I agree.
Yeah, was in my experience Stack Overflow the decisions of is accepted the best,
Yeah.
or is highest voted the best?
I think looking back now, something I would definitely do now if I were to do this again would be to exclude downvoted answers, because at least those are usually obviously bad. But yeah, whether the accepted one is the best one or the highest voted one, I would argue that these, without having the empirical data for it, I would probably say that an insightful sentence such as the ones we want in this scenario is just as likely to be in a not necessarily highly voted answer than it would be in the accepted answer. Because, as I'm sure you know, often the accepted answer is just the one that was posted first and that kind of thing. So we did have just to show you that this wasn't just completely random, we did have a coding guide that would sort of tell us what we consider a meaningful sentence and what we don't consider a meaningful sentence. So hopefully if I gave this coding guide to you and gave you the same sentences, you would get to at least pretty similar results. There will always be cases where it's like, one person says it's meaningful, one person says it's not meaningful, and you can't really say what's true. But we tried to keep this as objective as we could. The coding guide had lots of examples as well. Okay, so this gave us our development set, which had, I think, about 200 meaningful sentences and about 1,300 not meaningful sentences, so it's a bit imbalanced there. And then, as good researchers, we wanted to start using existing approaches to do this first, right? You don't want to reinvent the wheel all the time. So we started looking at existing approaches to do this, and one of the communities we started looking into is the summarization community, because we were thinking, one way of conceptualizing what we're trying to do is, well, we want to create a summary of stuff on Stack Overflow that's related to this particular API type. And there's been lots of research in the summarization community already. There's some specific approaches such as update summarization. I have a few more detailed slides on this. Some existing approaches on knowledge patterns, and then finally our machine learning approach. But let's start with summarization. So to try summarization on this, we used an approach that's called LexRank, which is probably the most commonly used summarization approach. And LexRank basically works on a big messy network such as this. Each sentence becomes a node in the graph. Each edge in the graph is the similarity between two sentences, and there are different similarity measures for text. In this case, we use the cosine similarity, which is basically an extended, a bit more complicated version of counting how many words are in common between two sentences. So then you have this graph. The nodes are sentences, the edges are the similarities between the sentences. And you calculate something that's called the eigenvector centrality, which basically tells you how central each sentence is in this graph. And then you pick the first sentence that would be the most important in your summary, the second sentence, and so on. And this particular implementation of a summarizer doesn't tell you how many sentences to pick. So we actually experimented with a few different thresholds. So what happens if we only take the first sentence? What happens if we take the first two? And so on. And actually the next slide is much better to show this. So we tried a few different settings, only the first sentence, first two sentences, and so on. And the eigenvector centrality that the summarizer works based on, it's basically a number, pretty close to 0, as you can tell. And we also tried playing with different thresholds for this. In terms of evaluation, we looked at two metrics, the precision and the coverage, and I'll tell you what we mean by those. So the precision of any of these approaches is the fraction of sentences that are meaningful. That one's pretty straightforward. So if our approach extracts 3 meaningful sentences and 2 meaningless sentences, then our precision is 60%. The other metric that we wanted to look at is the coverage, which we defined as the ratio of API types with at least one sentence, because an approach that wouldn't be very useful is one that has a really high precision, but for the vast majority of API types, it just doesn't find anything. In this case, we decided not to go for recall, because recall is really hard to define, because there might be more sentences on Stack Overflow that could be relevant to this. And recall was also sort of limited by our decision to only look at the 10 most relevant Stack Overflow threads per API type. So to have a really good handle on recall, we would, in theory, have to go through all of Stack Overflow and find all sentences that might be meaningful, and that just didn't seem like a good use of our time. If you've been following this, you might have realized that by definition, the coverage of these 5 options is always 1 because we take the most important sentence or up to the 5 most important sentences for each API type, which means by definition we'll find at least 1 sentence per API type. The coverage for these like score-based things with the thresholds could be lower. The results did not look very good. The best precision we got was 40%, so the majority of sentences that this approach pulled out were still meaningless. And as you can see, if we include more sentences, if we have lower thresholds, higher thresholds, it doesn't really help either. So in summary, LexRank, or this like state-of-the-art text summarization tool, didn't seem to work too well for what we were trying to do. Any questions about this, Hamish?
I was thinking, could you look at, I guess, the tone of the sentences to work out what's relevant? Because I guess with API documentation, not as the main factor, but I would have imagined API documentation sentences might be, I don't know if bland's the right word, but like not so much emotive or emotive tone, but very looking at just trying to lay out the facts, and if you could look at those areas.
Yeah, you're definitely going in the right direction there, yeah. Actually, something that we haven't tried yet is, so there's been quite a bit of research over the last 5 years maybe on, what's that called, like emotion detection. Some researchers in our community really don't like it, some do. But that's something that we haven't actually tried. That might work as well. But something not too different from what you just said was something that eventually worked. The next thing we tried was something called update summarization. Update summarization is something that comes from the news summarization community. And the idea is basically, the assumption is that you're familiar with yesterday's news and you just want a summary of the update in today's news, right? You're familiar with yesterday, you just want a summary of the update that you find today. Applied to our problem, you're familiar with the API documentation, you just want the update from Stack Overflow. You don't want the stuff that's in both sources, you just want the update, you just want the difference. So we thought that could maybe work. We used something that's called maximal marginal relevance, again from related work, which is actually based on the LexRank implementation that I showed a couple of minutes ago, and it subtracts from that score the maximum cosine similarity with any sentence in the API documentation. So it basically uses that same graph-based approach, but then punishes sentences that are very similar to the yesterday's news, in our case, the API documentation. Again, this was based on related work. So this was something that we thought we could try. Same results table. Again, the coverage for these 5 cases is by definition 1. And as you can see, the values went down. So this really didn't work. The best precision we had was 20%, which is pretty horrible. So this really didn't work. Summarization didn't work well. Update summarization didn't work at all. The next approach we tried, something more from the software engineering literature. This was actually an approach that was developed based on API documentation, and the goal was to find these really important sentences in API documentation that tell you that you must not do this, you must not pass in null, you must not assume that, this is a null check or whatever. You must not pass in sentences, values larger than 5 or whatever it is. In related work from 3 years ago by now, basically used a very systematic approach to extract patterns that such sentences contain. So should, recheck, caller, pass, must, some code word, should ignore some code word, and so on. So this is related work. They used some systematic approach, I can't even remember what they did in detail, to extract such patterns. And then they found that sentences that included such patterns in the API documentation were actually more useful. I think they defined it as indispensable. So these were the sentences that you should definitely not delete from API documentation because they tell you something really important. So we thought, okay, maybe these are the kinds of sentences that are meaningful on Stack Overflow as well. Turns out they were not. So this time our precision was 15%. So none of this really worked too well. Summarization, update summarization, knowledge patterns that worked well on API documentation do not work on Stack Overflow. And I think a lot of it is, Hamish mentioned the tone of sentences. I think a lot of this is because API documentation uses quite a different language to Stack Overflow, even though they are quite often talking about similar things. Okay, machine learning to the rescue. So we developed something that we called, so all of the approaches so far were unsupervised. So then we developed something that we called supervised insight sentence extractor, or SISE for short. Machine learning, this was before the days of deep learning, so we actually needed to do feature engineering. We had lots of features in there. You don't need to read all of this, but the basic idea for these features here is they are sort of the obvious things. If you want to design features for a sentence on Stack Overflow, you can look at, the score of the surrounding answer. You can look at the score of the question that this answer belongs to. You can count the number of characters. You can count the number of characters that are code. What else do we have here? You can count how much time it took from the time the question was posted until this particular answer showed up. You can look at the relative rank of the answer based on the score, based on the time. You can look at whether the user was registered. Is it just the user that, this is the only answer he's ever posted, or do they have a strong track record on Stack Overflow, and so on. So basically all the sort of obvious numeric stuff. Now the numeric stuff doesn't really help you understand what kind of sentence it is, right? It doesn't get you to the tone or whether it's meaningful and so on. So we added a few other features as well. One was based on the sentence itself, which is a string feature, and the other one was part of speech tags. Now, machine learning likes numbers and they don't like strings that much. So we had to transform the sentence and the part of speech tags into numerical features. Let me show you how we did this using an example. So this is actually a sentence from Stack Overflow, which says list is slower than arrays. I haven't checked if this is actually true. So one thing that's pretty easy to do is to have one feature for every word. So for each sentence you can count, well, how often does it contain the word list? How often does it contain the word is? How often does it contain the word slower, and so on? Well, to do this a bit better, we actually replaced list and everything else that was in TT tags in the original source with just the word code element, so that it wouldn't matter what code element it is. And we also did some normalization or lemmatization in this case of the words. So instead of counting is, we would count be as the base form of the word. So each word becomes one feature. In addition to that, we looked at bigrams and trigrams of words as well. So in this case, we have code element B and B slow, and we also have code element B slow. Then what would be the next one? B slow then, and then slow then code element. So every word becomes a feature, every bigram becomes a feature, every trigram becomes a feature. And we do some pre-processing, we normalize the words, and we replace all code elements just with a special token code element. That gives you a lot of features, but this wasn't quite enough features yet. Hamish?
What happens with word lists, I guess, is a word like can be used as a code element, but also as normal.
Right.
Like the common word.
Good question.
What is that?
So in this case, we treated as code elements those that had HTML formatting to indicate that they were code elements in the original source, and also ones that met at least one of, I think it was about 30 regular expressions. So if it started with an uppercase and it was in the middle of a sentence, which, chances are you weren't talking just about listing things in general, you were talking about the API element list. So code elements were detected based on the formatting in the original source and whether they matched a particular regular expression. So these were the word-based features, and then we did something very similar with part-of-speech tags. For those of you who are not familiar with part-of-speech tags, it's one of the first things that natural language processing gives you if you give a sentence to natural language processing. So if you give a list is slower than arrays to a natural language processing library, it will tell you that list is a noun, is a verb in third-person singular, present tense. Slower is a comparative adjective. Then I have no idea what that is. I can't remember now. And arrays would be another noun. So this is something that we didn't re-implement, of course. There are existing libraries for this. And we used a similar approach. Each part of speech tag became one feature. Each bigram of part of speech tags became a feature, and each trigram as well. And you'll see why these kinds of features are useful shortly. So this was how we attempted to sort of capture the string features of a sentence in a way that machine learning could do something useful with it. And we added two more features in based on the similarity between the sentence on Stack Overflow and the API documentation. We looked at the average and the maximum for this. And these two features were based on this idea of update summarization. We still believed that there was something important about whether a sentence was similar to the API documentation or not. Okay, we played with different machine learning algorithms. We played with different settings and so on. The best thing we managed to get was a 64% precision, which is quite a bit better than the baselines I showed you earlier. And we managed to cover 7 out of the 10 API types in our training data. This was based in the end on a support vector machine and attribute selection at an information gain threshold of 0.02. We played around with different information gain thresholds. This was the one that gave us the best performance. Why did we do attribute selection? Because based on the way we constructed string features, we easily have thousands of features in there. And machine learning sometimes doesn't work as well if you have too many features. Often it makes sense to limit it to the features that give you the most information, in this case, the most information gain, and then the overall performance of machine learning actually tends to be better. Something else we did was, we called it 10-type cross-validation, so it wasn't just a basic 10-fold cross-validation. So because in our development set, which in this case became our training set, then we have sentences that are related to 10 different API types. We would train it on sentences belonging to 9 of these types and testing it on the 10th one to make sure that we don't bias our approach too much by the particularities of one particular API type. Okay,
And your precision
Marcus.
there is now the average? Or
Average, yeah. Okay, which features actually turned out to be useful? There's one typo on this slide. I'll see if anybody finds it. Which features turned out to be the most useful ones? Interestingly, let me just highlight the ones that I want to talk about. Interestingly, what turned out to be really useful was something that we tried to avoid when we did the update summarization approach. So it turns out if a sentence on Stack Overflow is similar to the API documentation, it's actually more likely to be useful than if the sentence is quite different to the API documentation. Because sentences such as not too shabby, they use very different words to the API documentation. Whereas sentences that also talk about data source and driver manager, they are quite similar to the API documentation, and those are the ones that turned out to be useful. So it turns out what we were trying to do with update summarization was actually the opposite of what we should have done. We should have looked for sentences that were similar instead of trying to avoid them. So this turned out to be, these two actually turned out to be the most useful features. Then we have quite a few in there that you would sort of expect: answer, score, answer, age, question, score, and so on. But just to show you that all the work we did with natural language processing paid off as well. One of the features that was useful, number 11 there, the number of nouns followed by a verb in present tense, third person singular in a sentence. And then number 13, the sentence starts with a noun followed by a verb in present tense, third person singular. Why is that? Because sentences that have these features look like definitions, basically. Data source is, driver manager does. These sorts of sentences way more useful than not too shabby. And things like, the number of occurrences of the verb to be was quite useful as well. Anybody spotted the problem on this slide?
What is favorites in
Yes, I was actually looking for a more serious issue. But yes, I was still living in North America when we did this research, so we didn't use the British spelling. Answer score is in there twice, 4 and 17. I've given this talk dozens of times. Finally, somebody in Japan managed to find this typo. So actually something went wrong when I put this slide together. The first answer score is correct, the second one simply shouldn't be there. So, but I was like, I think I'd given this talk for 2 years, and then I gave it in Japan, and somebody was like, why is that doing that twice? Anyway, so our first research question was, to what extent are these different approaches able to identify meaningful inside sentences? And what we found was that only the supervised approach, the machine learning approach that I talked about last, was able to identify sentences with reasonable performance values. Hamish.
Could you reverse the news update? So you said the news update was doing not what you wanted to do.
Right.
Could you almost just reverse it, and would that be useful?
We haven't tried it. Possibly, yes. I mean, in a way, the machine learning approach essentially did that, right? Which is partly why we didn't actually give it a try. It would be something interesting to try, though, yeah. The question is, how exactly would you reverse it? Would it still make sense to just replace the minus with a plus and see what happens? Then it gets into heuristic approaches and some random decisions that aren't really easy to back up with related work. But yeah, it might be worth trying. Yeah. All right. Second question: do practitioners find any of this actually useful, or should we have spent our time doing something else? To answer that question, we sent out a survey to software developers where we showed them, and just as a reminder, so this is where we then used the 20 API types from the evaluation set. So all the stuff so far was on the 10 API types. Now we're looking at the sentences belonging to the other 20 that we extracted using the stratified sampling. So we put together a survey where we showed them sentences. We had a total of 8 participants. That's how many we needed to cover everything. We showed each participant up to 4 sentences per approach and per API type. So we put all the 4 approaches in there: the summarization, the update summarization, these knowledge patterns, and our machine learning approach. Each participant got to look at 5 sentences belonging to 5 different API types, and we made sure that each sentence was rated by at least 2 participants to make sure we had some sort of inter-rater agreement there. So we put sentences into the survey, and then for each sentence we asked the participant to say, is this sentence meaningful and it adds something useful? It's meaningful but does not add something useful. It requires more context to understand, or it simply doesn't make any sense. And we put sentences from all the 4 different approaches in there. So LexRank, which is the summarization approach, didn't work too well. We only have 22.5% in the really green area, so meaningful and added something useful. A few that were meaningful but didn't add something useful, but most of them either required more context or simply didn't make sense. Interestingly, update summarization in this case performed a little bit better than the straightforward summarization, but still not very good. The knowledge pattern sort of in the same area. And then our machine learning approach is finally the one where we see a bit more green. So almost half of the sentences were meaningful and added something useful. Then we have another 22.5% that were meaningful but didn't add something, no additional information, and smaller portions that required more context or simply didn't make sense. So still lots of work to do to push these numbers even further, but it worked at least better than the baselines that we were comparing against. So to answer our second research question, do practitioners find these sentences useful? They found more sentences which contained useful information in the output of our machine learning approach compared to the baselines that we had from related work. We just say a couple of things about the threats to validity to this work. So whenever you do when you annotate data manually, there's always the threat that maybe in the annotation you bias the approach. In this case, it was practically impossible to favor an approach because we had this big spreadsheet with 1,500 sentences from Stack Overflow. We just went through and said yes, no, depending on whether we thought it was meaningful on its own. It would have been really hard to do this annotation in a way to favor our machine learning approach because we don't really know what our machine learning approach would use internally. And actually at the time we didn't even know we were going to do machine learning in the end. Development sets or training data can always be bigger. In this case, we had 1,574 sentences. They came from 309 different answers on Stack Overflow. So we have a bit of a coverage there. We also found that in the survey, so I said we asked at least 2 participants to rate the same sentence. So each sentence was rated by at least 2 participants. They only got perfect agreement in about half the cases. That's exactly because the question whether something is meaningful, yes or no, is subjective. So you can't realistically get much higher than that. And participants had different backgrounds, different experience. Something that might be meaningful to a beginner might not be meaningful to an expert, and vice versa. We cannot claim generalizability beyond Java. However, none of the features of the machine learning approach are Java specific, so I don't see why it wouldn't work for something else. And of course it only works, and I do get that question sometimes, oh, does this work if there's no discussion on Stack Overflow? Well, no. So of course it only works for things that are reasonably popular and are actually discussed on Stack Overflow. We don't create new Stack Overflow threads as part of this work. So to wrap this one up, we combine documentation from different sources, we define inside sentences, and our machine learning approach ends up working best. Before I move to the next one, we have a few minutes for questions, I guess, if there are any. Yes, Sam.
How does performance go with this? Because obviously you're looking at a very small subset of the API, and you're talking about potentially in the future using other languages as well. At the moment, it seems like there's a lot of work, even in just the initial scanning of the questions.
Yes, good question. It sort of depends on how exactly we implement it. So in a way, that was actually one of the reasons why we decided to rely on the Stack Overflow API, because so actually what we would do now, so say you actually want to implement this as a browser plugin, you get to the page of an API type, go to the Stack Overflow API to retrieve the 10 most relevant threads based on our criteria. That you can do with one single HTTP call. So that shouldn't be too bad. And you don't need to retrain the machine learning, you just need to apply it, right? So that should be pretty fast. Exactly. Okay. So I think it wouldn't be too much an issue. Of course, if we were to scale this up, you could think of all sorts of caching to make sure that you always have sentences for popular API types in the cache, and reevaluate, I don't know, every week or so to see if there's new stuff on Stack Overflow. Particularly if a new version of the API comes out, this could be really interesting to then reevaluate, reevaluate basically.
My particular concern was scanning all the questions and extracting.
Right.
So just maybe do all of that once and have to keep updating that and call back to a server each time, or?
Yeah, I guess. Yeah, I wonder where the trade-off, where the perfect place in this trade-off is. So one thing you could do is just download all Stack Overflow data every couple of months, basically when they release their data dump, pre-process everything, and then only work with the pre-processed data, which then could be really fast. You lose the advantage of having, I mean, right now the approach could give you real-time sentences, basically, right? If you post a new answer and it matches all the criteria, it would come up right away, which with a huge data set you wouldn't have. Yeah, it's a performance trade-off. It also depends on how exactly you implement it. So, you know, would you actually want it to be a browser plugin such as this one? Would you want it to show up in the IDE somewhere? Would you, I don't know, want it in the printed version of the API documentation? That's a bit less likely. So it sort of depends on the exact usage scenario. I think if you really wanted to optimize it for performance, download all of Stack Overflow, which Stack Overflow fortunately makes really easy, and pre-process everything. But then it should be really quick. Right. Any other questions? Does anything that you've learned in search-based software engineering look like it could be applied to this?
Well, the concern would be performance with that, because if it's evolutionary, you'd have to have a few iterations to find an answer, and it would probably be a bit tough to do.
But I mean, it could be pre-processed, right? So, right. So, assuming that maybe we can sort of exclude performance for a couple of minutes, assuming that we want to pre-process everything and we have the computing resources and all that. So you mentioned evolutionary algorithms. How would you apply them?
Probably need a heuristic to it, so the ones that you proposed before
Mm-hmm.
don't quite have the same quality as the deep learning,
Mm-hmm.
feature-based learning. So I guess you could use some of the features as heuristics.
Right.
Yeah, I guess what I see is that the issue is what do we really want to get? What's our fitness, I suppose,
Right.
which is almost like the size method already determines that.
Mm-hmm.
So you'd have to almost, unless there's other values we can look at, then you'd just be, I guess, searching on the sentence. So for the question of sentences, which really isn't ideal.
Right. So I guess you might use so you might use this approach as the fitness function, possibly.
Then I don't know how you kind of look at the search space.
Right.
This function.
Yeah.
What do you think?
Lots of design decisions there.
Right.
Lots of magic numbers involved.
Yeah.
Lots of alternatives that can be tried out. Well, it's all driven by fitness function, or at least a human in the loop, if possible. That can be a bit time consuming to evaluate. It could be something like, a person clicked on this or saw this, and next to it is a plus or minus button, and say, okay, this additional information is actually useful or not. So that can then be fed back into the background, and then some algorithm can consider this new information. So not just optimize it once, but just keep optimizing, essentially. Consider the user feedback. And this might then, over time, refine the model a little bit, and maybe a sentence like not too shabby might not appear anymore after a while. The question is, are the features that are used on the inside expressive enough, or can they capture this? So just downranking the same sentence over and over again, sure, the human wants that, but if it can't be captured by any feature, any sentence, any back of words, any cosine distance or so.
Right.
Because you wouldn't want to change a sentence, I guess this thing, because that almost for me,
It could be interesting too.
yeah, you don't want to really cut out a sentence and replace things with it. So I guess the thing I would look at is almost users would have to rate, as Mark was saying, rate certain sentences, and then extract those attributes, and then to refine the machine learning size algorithm. Because maybe, like looking at this example here, what was I thinking of? Well, a hash map is a hash map is a map based on hashing of keys. I mean, it's good, it's useful, but it's a bit of
Right.
like it's reiterating what
Yeah.
it's saying. So I don't know if you download that, give that a bad like a fitness score, and then those attributes are checked,
Right.
put back into the size.
Realistically, you guys probably know more about search-based software engineering by now than I do. At least if Marcus has been doing a good job. How much annotated data would we need to actually make this happen? So, we could have ratings for 5 sentences, which I'm assuming isn't enough, but well, do you have any sense for how much would be needed?
It's a trade-off. It
Right.
depends. That's the simplest answer. It depends.
But is there any, like,
1 million.
right,
Well,
that's
what's the question?
probably not realistic, yeah. I don't know, I feel like to create a reasonably working support vector machine for this kind of data, I usually go for a few hundred, but then there's a good chance that something useful will come out the other end. Well knowing that if you put more hundreds and thousands in, it will get better, but chances are if it doesn't work with a few hundred, then you're probably doing something wrong and it's just not going to go anywhere.
You just have tens of data points.
Right.
So many things can fit or not fit.
All right. So would you say a similar number for this?
Hundreds, yeah, but with a little star and footnote saying it depends.
Okay, right. But, like, okay. Because one thing I was thinking, it might not even be that unrealistic to do that. Because, I mean, manually annotating 1,500 sentences sounds like a lot of work, but it's not actually that hard. You look at the sentence, it's really obvious whether this kind of sentence is useful in this scenario or not, right? Not too shabby, you don't need to think about for very long to realize that this is not the kind of sentence you want here.
I wonder, would it be an idea to have a Stack Overflow plugin? So somebody's writing an answer, and then it gets feedback immediately saying, oh, what you're writing is not relevant.
Right.
So you turn that around. Or this has been covered by the API, and here's a link, so do you want to include this?
Might actually be even more important for the question.
Or even for the question, yes. True.
Yeah.
Like, Google the fucking question.
Yeah. We did a study on links on Stack Overflow recently, and it's shocking how many of those links there are. Apparently there's, what's the link? Can't remember now. So there's definitely, let me Google this for you, you must have seen that one, but there's another one as well that's basically, it's a link to a book that says something similar to, like, go find this yourself, maybe with some expletives in there. And I was really surprised how often that link appears in a comment on Stack Overflow.
Especially when you Google for it.
Yeah, it's, I don't know. I feel like sometimes, and I think Stack Overflow itself has realized this now as well. I feel like sometimes the community is a bit too harsh on things like that. Because I guess the additional value that such a link provides is pretty low. It's really just somebody venting, and I don't know.
I wonder what would happen, like in the context of this paper, if you came to an answer that said something similar, like Google it.
Right.
Like that would be another feature that would have to be considered almost, because it could say, it'd be hard to know if it's useful enough because it's different from the documentation.
That's right, yeah. Definitely be different
It's
from...
completely, it's got no context to the actual question.
Yeah. So yeah, I guess in a way our machine learning told us to not go for sentences like that, to only really go for the ones that are quite similar. Yeah.
So I think the similarity is the right way. I think if you go into unsimilar, you've got to get the not too shabby.
Yeah.
I assume, but then because that most of what's said there in that one is different to what's included in the interface API there. Some of it's not the most useful, but it's different to what's referenced there. But it's still relevant. Or if you've got
Yeah, I would say so. So my observation at least is, and I'm sure you've seen this as well, API documentation, you look at, let's stick with Java for the example, you look at one class and the API documentation only talks about this class. Very narrow, very thorough, because it actually has a sentence about every method, even the ones that you will never use, but very narrow. And what Stack Overflow can be really good at is showing you the context in which you might use this. So I think the last one here is, linked hash map is very similar to hash map, and it adds these extra things. I'm sure that information is not in there. Definitely not in map, but probably also not in hash map. Because hash map, it's almost like every class is just trying to make a sales pitch for you to use that class, but it doesn't give you this information of, well, here are some other things that you might also consider, and there's this other thing that has more features, and then you can make an informed decision.
Could you look at all the, so this map has the linked hash map and the hash map, could you list all the, instead of having an API documentation of what this is, have an API documentation of what it compares to?
Right.
So list all the alternatives to the list of the array, all those options there, and then look and see and get that information on the API.
Yeah, I think you could almost even do this in a pretty naive way, like find maybe threads. I don't know if sentences would still be the right way to do this, or maybe paragraphs on Stack Overflow that mention map, or in this case maybe map or one of its subtypes, and other API types. Just so, because those sentences will give you more information about alternatives and things like that.
Because then you're not getting some, like getting the repeated information, like stuff which is relevant but doesn't expand on much.
Right.
Do get to the other areas.
Exactly. Yeah. And I think coming back to your earlier point as well, you mentioned, I think, the tone of a sentence, right? I think in a way like this, sentences that look like definitions, that's sort of going in that direction. I think that's also something we could probably push further, so maybe even with emotion detection or things like that.
There's a sentence string which is probably just happy and sad, but there's also the tone analyzer.
Yes.
To the how informative or how, like not the how emotional is it, how important is the text.
Problem is, as I'm sure you've seen, sentences on Stack Overflow are not always written in the most perfect English, and actually this is something that maybe could have been interesting for this audience as well, but we don't have that much time to do all the talks here. One study we did recently, which had quite shocking results, really. Okay, so a lot of the stuff that I do is somehow related to automatically analyzing software documentation. Software documentation, usually written in natural language, so you generally use some sort of natural language processing to do things with it, right? And there are quite a few natural language processing libraries out there, so these are the kinds of libraries that tell you that this word is a noun, this word is a verb, and so on. And when was it, last year, I think, we did a study where we ran 4 state-of-the-art natural language processing tools. So Stanford is a really well-known one, Google has one, and a couple of others. So we ran 4 state-of-the-art libraries on Stack Overflow text, API documentation, and GitHub README files. And we found that on average, they agreed on about 60% of the tokens. So every 2 out of 5 tokens, 4 state-of-the-art libraries couldn't even figure out what this might be. Big problem, of course, code elements. Incomplete sentences, especially in API documentation, you often find things like returns the next page or something like that. Incomplete sentence. Natural language processing toolkits often trained on like the Wall Street Journal or something like that. Lots of financial data. They see the word returns, they think, oh, must be a tax return, must be a noun. Whereas, returns the next page, return is actually a verb. The natural language data on Stack Overflow or API documentation or GitHub README files tends to be quite messy. All right, any more questions on this one? Otherwise, I'll move on to number 2.
Time for a very short break.
Sure, yeah, we can do a 5-minute bathroom break.
5 minutes sounds good.
I have no idea where the bathrooms are, so don't ask me. Yeah, I think we'll only do 2 of the 3 then. I'm hoping you didn't ask all the questions about the third one.
All these questions can be easily answered by reading the papers. Very easily.
That's true.
Yes, they are true false answer questions, and the information is not deeply hidden inside the sentences, so don't worry about it.
Your microphone as well. That's time-wise, maybe up to 55 or so. Or in worst case, I'll have to leave early.
Yeah, I have a meeting at 1.
So all right. Yeah, that's right.
I'll try to finish at 50. All right, let's get started again. So this next paper I briefly want to talk about is about GitHub repositories. At least the ones that are doing SERP at the moment are familiar with GitHub. And the motivation for this work was that there's a lot of stuff on GitHub. If you look at GitHub's own statistics website, which is called Octoverse, and I don't think these numbers are even super current. Since September 2 years ago, there have been 1 billion public commits, 12 million active issues, 47 million merged pull requests. Some probably due to the SERP projects, but I don't think all of them. And of course, if you deal with that much data, you essentially deal with, you have information overload. There's just too much stuff. And as I'm sure you've experienced as well in collaborative software projects, you don't actually need to read every commit message. You don't need to read every issue and every pull request that happens on your project. But which ones do you actually need to look at? So this research project started a couple of years ago, and this was published in 2015 originally, and then this is follow-up work. But one of the research questions we had was, from a developer's perspective, what information should be included in a development summary? And the SERP students will recognize this kind of question from the Friday afternoon summary question. And back in 2015, we asked this kind of question, and we got a bunch of survey responses. We did some follow-up interviews, and some of maybe the most interesting question we had in that survey was, assume it's Monday morning, you're just returned from a week-long vacation, one of your colleagues has given you an update on the development activities last week. What information would need to be in such a summary? So we got lots of answers to that, and we were hoping that these answers would sort of generalize to other scenarios as well, but this is maybe a useful lesson if you do survey research. It's always a good idea to make the question as concrete as you possibly can, so to ask about a very specific scenario rather than a more generic, oh, what do you need to know about your GitHub stuff? So we got lots of interesting responses, did quite a qualitative analysis. This was a small part of our whiteboard. The qualitative details of this are material for another talk. But one of the themes that came out of this was that developers want to know about things that are unusual. And here are a couple of quotes that we got in the survey that sort of give you this, that resulted in us thinking that maybe unusual events were really useful there. So somebody was saying, the only important thing in such a summary is when something is not on track, when it's going faster than expected, and why. I have no idea why they said faster instead of slower. Another one said, you need to know about what functionality has been implemented, what has been tested, what were the challenges, and anything out of the ordinary. Or another one, description of the features they worked on, as well as any unusual problems, any anti-patterns they encountered. So developers in such summaries, in some form or another, want to know about things that are unusual. Like I said, we did a survey first, and then we did follow-up interviews. So we used the follow-up interviews to ask in a bit more detail, well, what do you mean by these unusual events? What do you actually need to know about? One developer said, well, if somebody hasn't committed anything in a while, his first commit after a long silence could be really interesting. Another one said, changes to files that haven't changed in a long time, changes to a large number of files, large number of deletions, and so on. So these were sort of the answers we had to play with. And based on these answers, it's really just a straightforward generalization of the things on the previous slide. We then put this hypothesis forward, which says that developers are interested in unusually large or small things related to commits, issues, and pull requests. As you know, commits, issues, and pull requests are probably sort of the cornerstones of GitHub, at least the ones that are changing the most often. And we saw people wanted to know about large commits affecting lots of files and so on. So to generalize this, we said, well, maybe they want to know about anything that's unusually large or unusually small, and we'll see how that goes. So what we did in this particular study is basically a systematic investigation of this hypothesis that developers want to know about things that are unusually large according to some metric or unusually small according to some metric. Now, the thing is, as I'm sure those of you who are doing lots of work with GitHub are well familiar with, artifacts on GitHub can be unusual in many different ways. I put a few marbles on this slide. So in the case of the marbles, they could be unusual because of their color, maybe their Y position, maybe their X position. Actually, this might even be three-dimensional, so maybe you have a Z position in there as well. They could be unusual because of their size, even though these all look the same size. So lots of different ways in which something can be unusual. And the same thing applies to commits, issues, or pull requests. Could have lots of files, could have an unusually long commit message, could have taken unusually long to make this commit since the last commit, unusual number of words, unusual number of different file types, lots of different ways. So, and with issues and pull requests, it's similar. So things could be unusual or can be considered unusual in many different ways. What we wanted to do in this work was trying to figure out which of these different ways in which something can be unusual would actually be considered useful by developers. So we have a few definitions for this. We said that an unusual event is an artifact that's unusual in at least one way. So for example, a commit that has an unusually large number of files added, and an unusual event type is a type of such a thing. So one way in which something could be considered unusual. For example, an unusually large number of files added in a commit. Let me show you an example. So this is, as you can probably tell, a closed issue from a GitHub project. It's LaTeX XML, which is a converter for LaTeX code to XML, HTML, and a couple of other markup languages. The issue has been closed. And if I highlight a couple of things here, you can see that the issue was actually tagged with won't fix, and it had 13 comments. Now, we don't know yet if this is unusual, but we do if we look at some of the distributions around there. In total, this project had 21 issues that had been labeled as won't fix, and the median number of comments on issues labeled as won't fix was 2, with the first quartile at 1 and the third quartile at 3.5. Given this information, now we know that 13 is probably an unusual number. What we don't know yet is if developers actually consider this useful. So for this particular one, we actually asked developers, and they said, well, this information is quite useful because there are so many comments in this won't fix issue. It indicates that there's some interesting discussion going on that spans beyond the particular issue. So it might actually be useful to be aware of that even though it's a won't fix issue, there's a lot happening there. Maybe you should just quickly scroll through the comments to see what's going on. The same is not true for all won't fix issues. So the goal of this work that I'm going to talk about now was to identify exactly these kinds of things. GitHub commits, issues or pull requests that are unusual in some way compared to other commits, issues, and pull requests with the same characteristics. So in this case, the issue is unusual because it has a lot of comments, given that it had been labeled as won't fix. Okay, what did we do to do this in a more systematic way? Downloaded 200 projects from GitHub. They were all original projects, so we didn't look at forks. We used some magic numbers to figure out which GitHub projects to look at, because as I'm sure you're also aware, GitHub has lots of projects that are just used for homework or something like that, with like 3 commits and nothing else. So based on related work, we used 500 commits and at least 100 pull requests or 100 issues as the cutoff values there. So in total, we looked at some 400,000 commits, about 60,000 issues and pull requests, and the details of the distribution are on there. So then we needed to look at metrics that could mean that something is unusual. We had metrics for commits, metrics for issues, metrics for pull requests. So I'm not going to go through all of them, but a commit could be unusual because there's been a large number of days since the last commit. Could be unusual because it added a lot of lines of code, or very few lines of code maybe. Deleted lines of code, modified lines of code, commit message, a number of comments on the related issue, number of files added rather than lines of code, and so on. Or it could be included in a lot of pull requests. That's the last one there. So we looked at the distribution of these values for all commits in a project, but then we also limited it to commits that had been merged versus commits that had not been merged, because maybe one commit is unusual given that it's merged, or another commit could be unusual given that it's not merged. We also grouped them by committer, so a particular commit could be super big given that it was made by Marcus, for example, because he usually just does one-liners because he puts all this brilliance into this one line. Whereas, maybe I do really big commits anyway, so a big commit for me would be nothing unusual. And we also linked commits to issues, the same way that we're doing this in SERP. So we just looked at the hash with the issue number and the commit message, and we also looked at then the labels of the issue, and we grouped the commits by the label. We did similar things for issues and pull requests. The metrics are slightly different. So for issues, we look at the length of the description, number of comments, number of labels, days that it had been open, and so on. And pull requests is sort of a mix of commits and issues, really. So lots and lots of different metrics according to which something could be considered unusual. And we used a formula from related work, really, to figure out if something is unusual. This is just a definition of an extreme outlier. So if something is 3 interquartile ranges below the first quartile, it's unusually small. If something's 3 interquartile ranges above the third quartile, it's unusually large. So applying this to all our 400,000 commits, 60,000 issues and pull requests, we find that a lot of things are unusual. That's unsurprising. So 30% of all issues can be considered unusual as an extreme outlier, no less, according to at least one of these metrics. 46% of pull requests and almost 60% of all commits are unusual according to at least one of these metrics. So there is a way that you can say, well, this commit is actually an extreme outlier given that it has these characteristics according to this metric. Now, I'm not claiming that this is useful information. That's exactly what we wanted to get at in this work. Which of these are actually useful to developers? So obviously a system that tells you for 60% of the commits that you should look at this because it's unusual is not useful. but maybe if we limit it to the things that developers actually consider useful, we could get somewhere more interesting. So the two research questions that we wanted to answer in this work was how are unusual events or unusual artifacts that are outliers perceived by developers, and which types of unusual events, or which are the different ways in which something can be unusual do developers actually find useful. Again, we used a survey for this. The survey sort of had your typical demographic information at the beginning and a bunch of concluding questions at the end. But the most interesting part of the survey, and this was a dynamic survey that looked different for each participant, the most interesting part was sort of questions about specific artifacts. So the question would be something like, take a look at this specific commit. Would you consider this to be typical and or difficult? And then they had a few radio buttons where they could say, well, this is a pretty typical commit, this is a difficult commit, not typical or not difficult. And we gave them half the commits or issues or pull requests that were unusual according to our definition, and also the other half that was not considered unusual, because we wanted to see if there were any differences. And for the ones that were unusual, we then showed them why they were unusual, and we asked them which of these different statements they actually found useful. And there's a text box at the bottom where we also asked them why they found it useful or not useful. So in this case, for example, we would say, this particular commit is an outlier in terms of number of lines of code modified for file type JavaScript with a value of 1033. It's the second one there. Most commits with these characteristics have values between 9.5 and 184.5 with a median of 49. So in this case, we looked at all the commits that changed JavaScript files, looked at the distribution of number of lines of code modified in JavaScript files, saw that the median was 49, first quartile 9.5, third quartile 184.5, and this one is an extreme outlier with more than 1,000. And the same thing applies to all the other things. So this particular commit was unusual in at least 5 different ways. And what we wanted to know is this information actually useful? So got a total of 140 survey responses, just over 1,000 ratings for the different artifacts in terms of whether they were useful and or difficult, because every participant got to rate quite a few of them. Over 2,000 ratings for the different checkboxes there, because one artifact could be unusual in many different ways, and 293 free text answers. Okay. The first thing we were looking at, and we used odds ratio to look at this is a log scale, was how are unusual events perceived by developers? And let me just go through some of them. The first finding was that things that can be considered to be unusual according to at least one of our metrics are perceived to be more difficult, about 2.5 times more, 2.5 times more likely to be considered difficult than things that were not considered unusual according to any of our metrics. So it seems that our metrics, even though we didn't necessarily design them that way, can be used as a proxy for how difficult something is. So that was 2.5 times. Interestingly, that was another design decision we made with the survey. We asked them about half of their own artifacts and half of the artifacts that were owned by somebody else on their team. And we also compared those ratings. Interestingly, they were less likely to perceive their own artifacts as difficult if they were unusual compared to the artifacts of other people on their team. So in a way, the metrics seem to work pretty well as a proxy for, or as a means to identify difficult stuff that your team members are working on, which is actually really interesting from a mentoring point of view. So if you have new members on your team, you can actually use this to identify that, okay, they are probably working on something difficult at the moment, so maybe they'll need help. There were some differences in terms of commits, issues, and pull requests as well. The most extreme value we got for pull requests. So a pull request that was considered unusual according to at least one of our metrics was 5 times more likely to be considered difficult than one that was not considered to be unusual. So you can see the values for typicality were not as interesting. The most interesting stuff was really about the difficulty. Okay, so as you saw on the earlier slide with a lot of text, we have lots and lots and lots of different ways in which something could be considered unusual. We do not claim that all of these things are actually useful. The ones that turned out to be most useful were these 6. So whenever there's a commit with a large number of lines of code modified, people found that really useful. When there's a pull request with a large number of comments, people found that useful. When there's an issue that has been open a long time, same thing. When there's an issue that has a lot of comments, given that it is labeled a specific way, so this is similar to the motivating example that I had. So when there's an issue that's labeled with won't fix, for example, and it has a lot of comments, even though it's a won't fix, then people found that useful to know. Commits with a large number of lines of code deleted, and commits with a large number of lines of code added as well. So out of all the, I think with all the different, if all the different groupings, we had a few hundred different ways in which something could be considered unusual. Only 6 of them actually turned out to be useful, which was kind of what we were expecting. We wanted to have that small subset. We also asked developers why they found something useful or not useful. So they were saying that, when reviewing the project history, reviews with a lot of comments could be interesting in terms of decisions. So if you have a lot of code review comments, for example, or issues with a lot of comments, there's a good chance that there are important design decisions captured in that. Ideally, these design decisions should then also be moved to, I don't know, the wiki or some other documentation format, but all too often that doesn't actually happen. Lines of code deleted relative to the owner can be a good measure of the difficulty of a pull request. So if you have to delete a lot of stuff, that indicates that maybe what you were working on is actually quite difficult. And having a long-standing issue could be an indicator of a difficult issue as well. So when we started this work, we found that almost 60% of commits could be considered to be extreme outliers according to at least one of the metrics that we considered. 30% of the issues, almost 40% of pull requests. When we limit this only to the metrics that developers actually found useful, the numbers are much more reasonable. So now we're at 15% of commits and less than 10% of issues and pull requests. So based on this data, it should actually be possible to now build a little recommender system that, whenever there's something unusual going on, can tell you, well, here's a commit that's unusual because of these particular characteristics. You might actually want to look at this. Here's an issue that has an unusually large number of comments. Don't just ignore it. You might actually want to look at what happened in the comments, and same thing for pull requests. Okay, so what did we find in this particular work was that our metrics sort of can act as a proxy for difficulty, and being aware of difficult work of somebody else on the team can actually help you prevent problems early on. So especially for those of you who are taking SERP at the moment, if you get a little notification that one of your team members is encountering difficulties and you haven't actually heard them say it, then you might want to check in what's going on. We also found that, and that was unsurprising really, there's a lot of recent work that found this, so developers value simple and easily understandable metrics over really complex ones. So something we found quite a bit in recent work is that if you want to develop this kind of maybe a recommender system for developers where you tell them, oh, you should look at this commit, you should look at this pull request. If you can't tell them why, they won't trust the recommendation. So if you just tell them, well, we have this deep learning model and it says that in this commit there's probably a bug, but we can't tell you where exactly it is, but here's the big formula that, or here's all the different layers of the neural network that came to this conclusion, they aren't going to believe that. They aren't going to do anything about it. So in our case, what we can do with this approach is we can say, well, you know, this issue is interesting because most of your issues only have this many comments and this one has this many comments. This commit is interesting because most of the commits add 5 lines of code and this one just added 1 million. So what we're working on now, actually I have a team of master's students working on this at the moment. It's basically a feed of unusual events that developers would hopefully like to be kept aware of. Yeah, I can take a couple of questions about this and then maybe I can just quickly go through the third one that I had. Any questions about this? Everybody's fallen asleep, not
so
Hamish.
It's like a weekly report.
Similar.
So how does that differ from the idea of a stand-up? So if your company's doing a stand-up, how will this differ and will it? So is this only useful for companies where they, or public repos where there is no
that right. I think that too. Another way that this can be super useful is, and we deployed a really early version of this at a company in Brazil a few years ago, and they found it really useful to actually inform their stand-up meetings. Especially if you have new developers on the team and, you know, some developers are really quiet and they might just say, oh, no, everything's on track, everything's fine. Just as more from a manager point of view, it can be really important to know that they are dealing with something that's unusual at the moment. So if they've just been, you know, committing lots of code to files that usually never get committed to and they don't mention that in the stand-up meeting, that could be something where you're like, what's going on there? So while you're dealing with Geekbot on a regular basis at the moment, you know, a way that you could almost look at this is, you know, Geekbot actually asking you more specific questions. Instead of, you know, just, you know, what's been going on, you could ask, I noticed there was an issue with a lot of comments. Can you just quickly summarize what's happening there? I mean, in teams of like 4 people, like in the case of SERP, this is probably less needed than in larger teams, especially when you have different levels of seniority as well, and you might be bringing on new developers, then this kind of thing might be more useful. I'm assuming in SERP, because, you know, you read each other's stand-up summaries, you have a much better idea of what's going on, and you probably have a pretty good feel for when somebody might be struggling. But if you have a much larger team and, you know, you're more in a managerial role and maybe you manage a few teams, then this kind of stuff could actually really help inform the stand-up meetings. Any other questions? Any way that we could use search-based software engineering for this? I sort of picked all my talks that have lots of numbers in them because I thought that's what you people deal with.
Fine-tuning, squeezing out a few more percent.
Right.
Customization could be interesting. Developer A prefers this kind of feedback. Developer B prefers this kind of feedback. It's possible once you have a decent amount of data.
Yeah.
The question again is the overhead reasonable? You want something that people want something that is usable.
Mm-hmm.
Is it enough to be okay in just more than 50% of the time?
All right.
So if you manage to like you had your green bar and the yellow bar, if you make the sum go from 60% to 65%, 70%, and the variance stays the same, everybody might be happy. It might not be a super. You might still have that not too shabby sentence somewhere. Tough luck. But at least on average, you're getting better.
Right. Exactly.
So customization, yeah, per definition, it's possible. Is it worth the effort?
Right.
Similarly here, yes, parameters can be fine-tuned. Is it worth the effort? There's so much other work that goes into setting up the framework, collecting the data in the first place as well.
Yeah.
I mean, since now you know about optimization, one can squeeze it in here and there,
Right.
just fine tune it and to push it against the wall to the extent possible to see, okay, what's the limit of the technology. But afterwards, revisiting it and then just fine tuning the parameters is, I'm not sure whether it's going to reveal much.
Right.
Assuming that the work here has been done very rigorously.
More or less.
More or less, so going from in machine learning area, when you have a neural network and your prediction accuracy goes up from 90 to 92%, somebody might get a best paper award for that.
Mm.
In some other fields, they might say, meh,
Yeah.
2%.
That's right.
Depends.
So one thing that we struggled with a little bit with this work, and reviewers have pointed out as well, is that there are many different ways of defining outliers, right? What is unusual, what is not unusual. The definition that we used works best when it's a normal distribution, which we have no idea whether it is. Most likely it's not. Is there anything that, I don't know, does optimization deal with outliers very often? And if so, how do you decide what an outlier is?
It really depends. Yes, maybe the approach can be adjusted a little bit.
Right.
What's the side effect? So what are the benefits then to which extent does a system become a lot more useful?
Right.
Without the entire framework, optimization can't do anything.
Mm-hmm.
So it's not useful. Once you plug it in, can it help you to get from 60 to 65? It most likely, assuming that everything has been done just very thoroughly and systematically, it won't get you unlikely to get you from 60 to 95.
Mm-hmm. Right.
Maybe with unlikely.
If you're really
It
lucky.
can happen.
Right.
If you start off with really bad parameters and really bad systems, and you just take something off the shelf, and at least you can play with a couple. You do a random search essentially. There's a small chance, but then hopefully the field would say, no, 60% is not what you need.
All right. Makes sense.
But it's at least knowing about technology that is out there and saying, okay, I give that a try. I spend a day or a week
Mm-hmm.
squeezing the last 3% out of this. I know there are 20 different design decisions that I can make, 5 different parameters to set. There's technology out there that lets you do that, that lets you see that as a black box.
Mm-hmm.
If you want to know more about this, then you have to go into the black box and
Right.
exploit the more knowledge.
So if we wanted to use something like that here, we have to, put it together in a nice web application and get lots of people to actually rate what they find useful and what not, and then optimization could steer it in the right direction, right?
And to have the human in the loop continuous feedback.
Right.
That's quite a big thing also deployed in companies to
Right.
consider the feedback.
Right.
To update models.
Exactly.
But you need to have it deployed. Then it becomes a tool to enable other work.
Right. Because the main reason why I put this slide on again is there are magic numbers in there, which I don't really like that much. In this case, we could point to related work which have used the same magic numbers, but that would be something that would be really nice to not do completely magically. All right, I think we might as well wrap it up then. Any more questions for me? No? Everybody's happy? All right, well, thanks for listening.
Thanks so much, Mr. for dropping by this morning.
No problem.
Whether your slides can be made available. The
They can.
papers are definitely linked to
Yes.
from the course page. Maybe the slides.
Yeah, I'll send them to you.
All right. Next week, Wednesday, we have one tech support session for assignment 3. So ideally, all of you come, plus all the others. So I'll send one more reminder. So in case you have technical questions, raise them there. President Newton raised them on the forums as well. This is also an opportunity to share a bit and to see whether you're on track with respect to given the progress of the other teams as well. So it's an opportunity for you also to get feedback before you just get the mark in 3 weeks' time. All right. See you on Wednesday. Good. Thanks. That was good.
maximum.